Hello! In this video, we're going to be identifying the key features of a quadratic. So let's first take a look at the parts of a quadratic. There are several things that you're going to need to know. These are vocabulary words that you may end up having to just memorize. So the first thing is our roots, or our zeros. These are basically your x-intercepts. It's where it crosses the x-axis. You have a y-intercept, and that's where it crosses the y-axis. And you also have something called the axis of symmetry. Now, this is not something new. We've already been working with that when graphing a quadratic. And the last thing is our vertex. Let's take a look at each of these individually. So our axis of symmetry, that's this red line that goes through the middle here. And that's basically a line of symmetry. If I were to fold this graph on that line, my two parts would actually line up. Now notice this is always going to be a vertical line. Just as a quick review, if you remember graphing lines, a slanted line is in the form of y equals mx plus b. A horizontal line is a y equals line, and a vertical line is always an x equals line. These will always be vertical, and therefore these are x equals something. Now in this case, this is going to be x equals 4. So if I take a look, the equation of this line, whoops, let's bring this over, is the line y is equal to negative b over 2a. That formula actually comes from the quadratic formula. It's everything in the quadratic formula except for the radical. Now, if you're wondering where you get your a, your b, and your c from, well, your a, your b, and your c are going to come from the standard form of a quadratic equation. So you have to put it in standard form first, and then you're going to take the a, the b, and the c right from there. So if this is my function right here, 1 would be my a, and negative 8 would be my b value, and I would just plug this in. So x is equal to negative 8 all over 2 times 1. So that would be x equals 8 over 2, which means x is equal to 4. And you can see that this line is x equals 4. Moving on that line, on that axis of symmetry, you're always going to have this point. It's either going to be a minimum point or it's going to be a maximum point. That is known as our vertex. It is a turning point. It's where this function stops decreasing and then starts increasing again, or vice versa. So now, in order to find that vertex, first thing you need to do is find your x value. You're going to find your x value using your axis of symmetry formula. Once you have that x value, you're going to plug that x value into the equation, and you're going to solve for y, and that's going to give you your x value and your y value. So in this case, we know that this is the line x equals 4. If I just plug that into the function, and the function is x squared minus 8 times x plus 10, if I just plug in my 4 squared minus 8 times 4 plus 10, my y value is 16 minus 32 plus 10. So 16 minus 32 is negative 16. Negative 16 plus 10 is negative 6. So therefore, the coordinates of this must be 4, comma, negative 6. And this vertex is always on the axis of symmetry. All right, so your minimum and your maximum. So basically with these, you either have a minimum or you have a maximum. So let's just look at these 4 right here. Given the way this first one is drawn, what you have here is a maximum value. And that value basically would be, okay, how high or what is the biggest value of the function? Your biggest value of the function would be your output. So the highest output here would be y is equal to 2. Now you have to be careful because if the question is worded, what's the maximum point, you'd have to give coordinates. But if it just generally asks for the maximum value, then you're just looking at what's the highest value that the function reaches. So in the next one, this one would be a, minimum value. So that one is a minimum value. And again, we'd have to look at and see, okay, what's the lowest that this goes? The lowest that this goes would be -3. So the minimum value is -3. So the least output, the lowest that this goes, is -3. So now this one would also be a minimum value. Whoops. Let's get our selecting here. There we go. This one would be a minimum, and this would be a maximum. So if we take a look at that, the lowest that this goes here is 1, and the maximum, the highest that this goes, is 4. So again, if it just asks for a maximum or a minimum, you're just giving the y value. If it asks for a point, then they're really asking for the vertex, and you give the coordinates. Okay, you're finding your intercepts. Now this was tricky for us in class. Now we've done this before. When you're looking for your intercepts, if you're looking for the x-intercept, okay, that's special. That has a name called roots or zeros. So they could ask you to find the x-intercepts, they could ask you to find the roots, or they could ask you to find the zeros. So if we take a look at this line right here, on the x-axis, something is always true. On this x-axis, something is always true. So let's take a look at what's always true. Okay, so if you look at all the points that are on this line right here, something is the same. Something's going to be the same everywhere on this line. So if I look at that, and let's go with another color here, you'll notice that this value right here is the same going all the way across. And that value is always 0. So on the x-axis, your y value is always 0. So to find the x-intercepts, you plug in 0 for y. Now let's talk about your y-intercept. So here I have this vertical line right here, which is right on the y-axis. And if we take a look, all these points on the y-axis all have something in common. They all have an x value of 0. Therefore, to find the y-intercept, you're going to plug in 0 for x. So to find the y-intercept, you plug in 0 for x. To find the x-intercept, plug 0 in for y. Okay, so you're going to plug 0 in for the opposite value, and this is the reason why. Okay, the other thing that you have to be aware of with these is that when you're finding the roots, it is possible to have 2 real roots or zeros. So in this first example right here, you have 2 roots or 2 x-intercepts or 2 zeros, however you want to say it. But you have 2 x-intercepts, which means you have 2 real roots. In this case, the parabola only touches that once. So this one, you only have 1 real root. Now in this last example, it doesn't cross the x-axis at all. Therefore, it has no real roots. So just so that you're aware, you could have 2 real roots, 1 root, or no roots at all. All right, let's find some of these algebraically. Okay, so in this first example, we're going to first start with the axis of symmetry. That's our formula x equals -b all over 2a. So your a value is 1, Your b value is negative 16. So this would be x is equal to negative 16 all over 2 times 1. So that would mean x is equal to 16 over 2, which means x is equal to 8. So we're going to box that. Your vertex, now that you have your x value, all you're going to do is you're going to plug that x value into the equation. So it's y is equal to 8 squared minus 16 times 8 plus 64. So y is equal to 64 minus, okay, 16 times 8. 8 times 10 is 80. And then we have 8 times 6. Okay, let's do the math here. So we have 128 plus 64. Lo and behold, that gives us 0. So your vertex is a point, and it's, take your 8 and you put it here, so 8, comma, 0. All right, maximum or minimum? Okay, so if I were to graph this, one of the things that we're going to get talking about, that if this leading coefficient is positive, then your quadratic here is going to be a smiley face. Something like that. So what I'm going to have here is actually a minimum point, and you're welcome to graph this on your graphing calculator to double check it. The minimum value that this goes, if your vertex is 8, 0, the lowest that this goes is 0. So the lowest value is 0. Your y-intercept. Okay, your y-intercept, all you're going to do is you're going to take your function, your equation here, and you are going to put in 0 for x. So y is equal to 0 squared minus 16 times 0 plus 64. What you're going to notice is that's 0, that's 0. So the only thing that you're going to be left with is 64. So your y-intercept is 0, 64. Or I'm fine if you just said y equals 64. That's fine. Okay, your last one, your roots. So to find your roots, you're going to take the same equation, but this time you're going to put 0 in for y. Okay, so now all we have to do is solve this. You can solve it by completing the square, quadratic formula, or factoring. I would always try factoring first. And this is something that's factorable. So what multiplies to 64 that adds to negative 16 is negative 8. Notice that these two are the same, which means that this is only going to have one real root. So that means your x value is 8. When we are talking about roots, you only give the x value. So we will only give the x value. In this case, for the y-intercept, I'm fine with either one of those. Doesn't matter to me. But roots or zeros, specifically, if it says roots or zeros, you have to just give the x value. You don't give the ordered pair. All right, let's try another one here. Axis of symmetry. That's your x equals negative b all over 2a. So a is 1, b is negative 2. So it's x equals negative 2 all over 2 times 1. So x is equal to negative 2 over 2, which means x is negative 1. To get your vertex, you are going to plug that number into your function. So we're going to put in the negative 1 right here. So this would be y is equal to negative 1 squared minus 2 times negative 1 minus 15. So y is equal to 1 plus 2, that would be 3, minus 15. Okay, so I'm looking at this going, wait a minute. I don't think this is right. I made a mistake. Hopefully some of you saw it and noticed it. My mistake is right here. It's actually a positive 2, therefore this is a positive 1. So I'm going to go back and fix this. This is positive 1. So that's going to be 1, and this is going to be minus 2. So this is going to come out to be negative 16. Kudos to those of you who caught that. So this is 1 comma negative 16. And this is x equals positive 1. All right, continuing forward. I graphed this on my Desmos just to double check, and I found that this kind of looks like this, which means it has a minimum. It has a minimum value. Okay, and that minimum value is y is equal to negative 16. Doesn't go any lower than 16. Your y-intercept, put 0 in for x. That's 0, so your y value is negative 15. I will take 2 answers for this. You could say it as this, or I'm actually fine if you give the ordered pair, which would be 0 comma negative 15. And your roots. So again, your roots, what you're going to do is you're going to take this equation right here, and you're going to put 0 in for y. And let's try factoring. So factors of negative 15 that add up to negative 2. I'm thinking x minus 5 and x plus 3. So x minus 5 could be 0, which means x could be 5. X plus 3 could be 0, which means x could be negative 3. So when you're giving the roots or the zeros, you only give the x values. If it asks for coordinates, you'd give both. So this has 2 real roots, 5 and negative 3. And if you go back to this right here, you can see that there definitely are 2 roots. All right, let's try another one real quick. If you end up with a situation like this, where it's out of order, you need to put it in order. Okay, axis of symmetry. So negative 4 all over 2 times 1. So negative 2. Your vertex. So y is equal to 6 times negative, 6 plus negative 2 squared plus 4 times negative 2. So 6 plus 4, which is 10, minus 8. 10 minus 8, that would be 2. So your vertex is 2 comma negative 2. I graphed this, and it looks like this right here. So I definitely have, let's get rid of that. I definitely have what's called a minimum. So my minimum value here is y is equal to 2. You're going to always notice that it's the same as your y value in your vertex. Your y-intercept, hopefully you're getting pretty good at this. You're going to put 0 in for x, so 0 squared plus 4 times 0 plus 6, 0, 0. So that means your y value is 6. I'll take that, or if you give me the coordinates, that would be 0 comma 6. And your roots. What I'm going to do is I'm going to take this equation right here. And I'm going to put 0 in for y. So I get x squared plus 4x plus 6. I'm going to try and factor that. Factors of 6 that add up to 4. Oh, factors of 6 that add up to 4. Well, I got 1 and 6. That's not going to ever give me 4. And I've got 2 and 3. That's not going to give me 4. These must be irrational. All right, I think I'm going to complete the square. Let's review that process real quick. So I'm going to bring this over here. Negative 6 is equal to x squared plus 4x. If you remember, to complete the square, we're going to take half of the 4, which is 2, and then square it. And I'm going to add that to not just one side, but I got to add it to both. So now I get negative 2 is equal to x plus 2 squared. Now I'm going to take the square root of both sides. Wait a minute. I can't take the square root of negative 2. Uh-oh. You know what this means? This means there are no real roots. No real roots. Now, I had already graphed it, so I knew that in advance. This is actually the picture that it draws, and it doesn't actually cross the x-axis at all. Okay, what I'd like you to do is go back to my website, and there's 4 questions I'd like you to try. Try not to go over 40 minutes, which means this video is 20 minutes. You work 20 minutes on that practice. Work on your own sheet of paper and message me if you have any trouble. All right. Good luck, everyone.